What's up, guys? Today will be a good one. I hope everyone had a good weekend. It was a long weekend here in the States. We celebrated Memorial Day yesterday for our fallen veterans, so it was a good day. Yeah. How's everyone doing here? I think today will be a fun piece of the guide, learning all about modules and functions. So we'll actually use our IDE today instead of staying in the Elixir shell. What's up, Wasim, Sasha, William, Hans? How's it going? Sorry if I butchered any names. I'm not good. I always need the internet to tell me how to pronounce things. All right, cool, guys. Let's just jump right in, huh? I will share my screen. Oh, yeah. I know I showed this on one of my last ones, my last live streams, but this is my cheat sheet. I added a few things since I shared it last. I added ectotypes, and I also added ASDF because I always forget how to switch versions and things. So I was like, I should probably add that to my cheat sheet. So that's this, and you guys can find it at elixirmentor.com. There's a little banner that'll pop up, and you can download it for free. You just have to give me your email. But come on, fair trade, right? All right, cool, guys. Let's open up Firefox. Oh, there's the banner. So that's all you got to do. Click on that. And let's go to elixir-lang.org. And we'll go to guides here. And we're going to pull up modules and functions today. All right. Oh, and I'm so glad my chat box is working. It's hit or miss. It's like flipping a coin. But when it works, it works. Oh, and if you guys missed my podcast on Friday with Jose, highly recommend checking it out. It was a good one. It's really good. We went over an hour and a half, like an hour, 40 minutes, and a lot of good stuff. Jose is a very awesome guy and very passionate about Elixir. So it's always good to see. It's always good to see that. All right, let's jump in. Modules and functions. In Elixir, we group several functions into modules. We've already used many different modules in previous chapters, like the string module. So like string.length. So length is a function in the string module. All right, cool. In order to create our own modules in Elixir, we use the def module macro. The first letter of the module must be in uppercase, and then we use def macro to define functions in that module. So the first letter of every function must be in lowercase or underscore. All right. So let's go ahead and open up our terminal here. We're going to just copy this example for now, and then we'll jump into using an IDE. So let's start our Elixir shell, IEX. I'll make this a little bigger as well. So if we go ahead and just create a module here, so if we do def module math, and then we do our opening do for the do block, and we can put a function inside of this. So we can say def sum, and it can take two arguments, A and B. And then we'll write our function right inside this module, A plus B, and then we need an end to end our function. And then we need another end to end our module. So now we have a module called math, and we can access our function inside of math by calling the module name dot and then the function we want, which is sum, and then we can pass in our two arguments and we get 3 back. So that is a function inside of a module. So in this chapter, we will define our own modules with different levels of complexity. As our examples get longer in size, it can be tricky to type them in the shell. Yeah, writing any modules in the shell is annoying. It's about time for us to learn how to compile Elixir code and also how to run Elixir scripts. All right, cool. So most of the time, it is convenient to write modules into files so they can be compiled and reused. So let's assume we have a file named math.ex with the following. Let's actually make a file. All right, so back in our terminal, let's exit this, Control CC to get out of that. And I'm gonna just CD to the desktop. And we'll make a directory, mk directory, and we'll call this math.ex. I'm not going to put a dot. It's just the name of the directory. All right, so we have that, and then let's cd into this directory, and we'll create our .ex file. And our .ex file is just going to be math.ex. So go ahead and do a touch, and then math.ex. All right, cool. So we have that, and now if we go ahead, we could open up our IDE here, but we're going to just do a quick example with a .ex file. So I am going to just go and do vim and open up math.ex. And now inside of this, to insert when you're in vim, just hit I, and then you insert. And we're going to create our math module. So def module, capital MATH, do, and then we can tab over, that's a huge tab, but we're going to do it. And then we can create our function here that takes two arguments, A and B, and it's going to add them together, A plus B, and then we'll end that function, and then we'll end our module here. And then to save in vim, just hit escape, colon, and then do a W for write and a Q for quit. And now we have our .ex file. And to compile a .ex file, we can just do Elixir C for compile, and then the name of the file we want to compile, which is math.ex. And now math is compiled. And one thing that I should point out is when you generate or when you compile a .ex file, it creates a .beam. And the .beam file is all the bytecode defined in the module. So if we were to go, if I were just to do like an ls here, you're going to see that we have our math file, and then we have our compiled beam file that was created from compiling. I should have showed you the directory before compiling it because the .beam wouldn't have been there. And now if I go into our IEX shell again, we have the math.ex files compiled, so we actually have access to that with math.sum, and we can pass in 1 and 2 for the arguments, and we get 3 back. So that's pretty cool. So we just compiled our own code, and then when we opened up IEX from our directory, it found the compiled code, and we have access to our module. All right, back to the docs. Where were we? All right, so this will generate a beam file containing the bytecode for the defined module. Yes, that's cool. We saw that. And then we were still able to access this in the Elixir shell. Now, Elixir projects usually are organized into 3 directories. _build, and this contains all like the compilation artifacts. And then you'll always see a lib directory, and this contains our Elixir code. So this will contain our .ex files. And then if you do, so when you do like mix new, all these will generate, right? And that's how you usually will create an Elixir project. And then you'll also have a directory with test. And you'll notice the pre-written tests that come with a new project, they'll usually be .exs files. All right, so when working on actual projects, the build tool mix, yeah, okay. So you'll use mix or mix new and scripting mode. All right, so scripting mode is the .exs. So in addition to Elixir file extension .ex, Elixir also supports .exs files for scripting. Elixir treats both files exactly the same way. The only difference is in intention. So .ex files are meant to be compiled, while .exs files are used for scripting. So this convention is followed by projects like Mix. For instance, we can create a file named, or called math.exs. And then we can just run it. We can execute it with just calling Elixir and running our script. So normally when you're just testing things out, you'll probably just create script files, because then you don't have to compile it and create .beam files and have those taking up disk space. So that is the difference between .ex and .exs files. So now if we were to just pull up our terminal, let's get out of the shell here, clear. I'm going to just back out of our math.ex. I'm going to make a new directory we'll just call this one math, and then we'll cd into math. All right. And now if we just create a new file, and we're going to say touch, and we'll call it math.exs. All right. And I'm not going to keep writing this module in the shell, because I feel like that would just be a little mean and torturous for you. So let's go ahead and open up VS Code. All right. So we have, let's see, this looks a little small. We have our math.exs file here. Nothing is here. Hello, Richard. I'm happy you're here to join us. All right. So if we were to create the same file we just made in the shell in our .ex file, we can write the same code in our script file here. So we can do def module math and make sure your module for naming conventions is capital. And then we'll have our do and end. And we can create our same function called sum and pass in two arguments, A and B. And then do our do end block for that function. And all we're doing here is adding A plus B. All right. And now we can, so everything is going to run in order when we run this script. So it's going to call our module. And if we put anything outside of our module, like IO puts, and then we call our math.sum function, .sum function, and pass in 1 and 2, this is automatically going to run when our script runs, and we'll get the output 3. So I'm going to save this, and if we pull up our terminal, and now we can just do, instead of Elixir C, we can execute a script with just Elixir. So we can just say Elixir, and then we can run our math script. And it will run, and look at that. The IO puts is 3 right there. So it compiled, or I shouldn't say it compiled, it ran our module, and then it allowed us to call our function and run that as well. All right, back to the docs. Where are you? All right. So because we used Elixir instead of Elixir C, the module was compiled and loaded into memory, but no .beam file was written to disk. In the following examples, we recommend you write your code into script files and execute them as shown above. All right, so moving forward, we're going to just be writing in script files and executing our scripts with Elixir instead of compiling them and also creating beam files. All right, a function definition. Inside a module, we can define functions with def arity2 and private functions with def p arity2. A function defined with def arity2 can be invoked from other modules, while a private function, that would be the p, def p, can only be invoked locally. So let's go ahead and add to our file here. So we're creating a private function. All right. So we're going to refactor a little bit. So inside of our module, now we're creating a private function with def p, and this is going to do sum. And it also takes 2 arguments, A and B. And then inside of this, we're going to be adding A and B together. And then from our sum function, we are now calling our do sum function. So do sum, and then we're passing in A and B parameters to it. So our public function here has access to the private function because it's contained within the same module. So now if we add to our IO puts, let's say IO puts, and we call math.doSum here and pass in 1 and 2, we're probably going to get a warning. Well, we'll definitely get the undefined function error when we try to run our script. So let's pull up our terminal again. And when we go and run our math.exs file, there we go. So it ran our original function, so it still works when we refactored it, but then we got our undefined function, and it says it's undefined or private. So in our case, it's a private function, so we don't have access to it outside of the module. All right. So function declarations also support guards and multiple clauses. If a function has several clauses, Elixir will try each clause until it finds one that matches. Here's an implementation of a function that checks if the given number is 0 or not. Okay, so we're writing a function that if it pattern matches to 0, we return true. If it's not 0, we're going to return false, and then we have a guard here that it's just making sure x is an integer. Okay, so let's go ahead and add that to our code. So if we add a couple functions here, if we have our def 0 question mark, and we are pattern matching, if the argument passed in is 0, then we return true. And if it doesn't match 0, we're going to take that argument and then we're going to put it through a guard. So we're going to check to see if it's an integer. And if it is an integer, then we're going to return false. Okay. So save that. And then let's see here. I'm going to just comment out these two IO puts. And we're going to run a couple more. So we're going to do IO puts. And now we can run math.0 and pass in a 0. And this will actually return a true. And then if we do IO puts math.0 and pass in a 1, we should get a false back with this one. And then if we try to do something that isn't an integer, IO puts and then math.0, and I don't know, in their example they pass in a list, so obviously that's not an integer, so our guard should catch that. And then they also have IO puts math.0 and they pass in a float or a 0.0, and since that's not an integer, we should also get a function clause error. So if we save this and go to our terminal again, I'm going to just clear this and let's run our script. And so in order, we first passed in a 0, so we got true back. And then we passed in a 1, we got false back. So that is cool. And then we get a no function clause error for 0 because our arguments was a list, and then it stopped running. So if I were to comment this one out and save it, now we'll get an error on our 0 as well. So there we go. So 0.0 is also not an integer, and then it stops running our code because we had a function clause error. All right, cool. Back to the documents. So the trailing question mark in 0 means that this function returns a Boolean. So this is very common naming convention with Elixir. You'll always throw a question mark on, like in a lot of other languages, you'll see like is true, or what's a better example? Like is underscore integer, right? If it returns a Boolean, you'll normally be throwing a question mark on there. But so in this case, we're checking for 0, and the question mark kind of just helps us know that it's going to return a Boolean. So to learn more about the naming conventions for modules, function names, variables, and more in Elixir, let's go to naming conventions. Let's check it out. Yeah, this is a good one to check out. I wonder... I'm going to add this link to the description of this video afterwards. because that'll be a good one. And we can probably, I'll actually do a video on naming convention. I think that would be a good one. Let's see if we have any questions. No. All right, back to reading documentation then. All right, so given an argument that does not match any of the clauses, it raises an error. Yeah. So similar to constructs like if, function definitions support both the the shorthand version of the function or the do block syntax, as we learned in the previous chapter. So for example, we can write any function in the shorthand version. So if we were to write, let's go refactor our code. Let's pull up our VS Code again. I'm going to just comment out our errors. We know that works. So we can actually, instead of doing the do block like this, we can refactor this to the shorthand version. So we can do def 0, and if a pattern matches to 0, then you can just do comma, do colon, true, and that function's done. So when things are very simple, like the simplicity of writing a shorthand function just makes sense when it's really easy to read and understand. So I think that's pretty cool. And then we'll do the same thing for def 0, x when is integer. All right, and then comma, do colon, false. And then we'll comment out the longhand version. So now we have just two very nice and legible functions using the shorthand version. And when I go ahead and run this code, we're going to get the same outcome. So we got our true and false. Pretty cool. Shorthand notation, or whatever you would call it, is useful. All right, back to Firefox. All right, and it will provide the same behavior. You may use do colon for one-liners, but always use do blocks for functions spanning multiple lines. Yeah. If you prefer to be consistent, you can use do blocks throughout your code base. That's also true. So I guess it just kind of depends on personal preference or project requirements, because sometimes projects will want to follow, a certain protocol. I'm going blank what I want to call it right now, but like a linter, but code requirements for the project. Like Hired Gun Apps, my dev shop, we have particular ways we like to accept code, like tabs versus spaces and things like that. So if you don't like to use shorthand functions in your code base, that could be a thing. And sometimes it's just good to follow those guidelines, right? All right, default arguments. All right, so function definitions in Elixir also support default arguments. All right, and you can have a default argument with this backslash. So let's go ahead and go back into our VS Code. We'll create a new file, and we're going to call this concat.exs, and then we'll create our module here, module, and then concat with a capital C. Oops, I hate when. There we go. Def module. Got to spell things right. So if we were to create this join function that is in the documentation, we're going to say join, and it looks like it takes 3 arguments and 2 of them are required. So we're taking an A argument, a B argument, and then it looks like the 3rd argument is what we're separating the 2 arguments with. So it's called sep. And then by default, it's just going to separate them with a space. And then we'll do our do end block here. And then we're just concatenating. So we're taking argument A, concatenation operator, less than, greater than, and then what we're separating it with, and then concatenation operator, and then B. All right, so that is cool. And then down below, we'll do our IO puts like before. And we'll say concat.join. And if we pass in hello as a string. And then our second argument is world. By default, this is just going to be concatenated together and separated by a space. So we don't have to add the space on world or at the end of hello anymore. So that's nice. And then we can also not use the default separator of a space, and we can put our own in. So we can do IO puts and then concat.join, and we can say hello world, and then we can pass in a third argument, and we could say we want it to be separated with an underscore. All right, so if we save this and jump back to our terminal, and now if we run our EXS file called concat, so we'll compile and run that script, we're going to get back our hello world with a space by default, and then when we passed in the third argument of underscore, now it is separated with an underscore. All right, so that's cool. So any expression is allowed to serve as a default value, but it won't be evaluated during the function definition. Every time the function is invoked and any of its default values have to be used, the expression for that default value will be evaluated. All right, that's good to know. All right, so let's see here. Let's create a new module called default test. So back to VS Code. Let me check in on you guys. All right, cool. All right, we're going to create a new file. We're going to call this default test.exs. And if you notice, whenever I create files, they're all lowercase, and then you'll separate usually with an underscore. And then when you create the module, you say def module, and then it's just camel case. I don't think camel case is the right word when it starts with a capital, but you know what I mean. So default test, and then we'll do our do, and I hate that. There we go. So we have our default test module now. And if we were to create a function called do work, and I'm going to just do underscore work. I don't know why that bothers me so much. And then we're going to take an argument X, but we're going to have a default value of hello. So if no argument is passed, it's going to return hello. All right, so now let's see here. Let's go back to our documentation. Default arguments, an expression is allowed to serve as a default value. All right. Okay, so we're back in the shell. Let's see, let's just do this. Let's see what happens. So we're going to go to IEX, and then if we have our default test, I might have to compile this. Compile default test, undefined function. Is it C? Oh, you know what it is. I think it's C, and then I have to do a string default test dot. Oh no, it's the name of the file, default test.exs. Okay, and then if I do default test.do underscore work, we don't pass in anything, right? And we get our default value back. So that's cool. And then if we pass in a value, we get our value back. And then if we don't pass in anything again, we get our default value. Okay, so if a function with default values has multiple clauses, it is required to create a function head, a function definition without a body, for declaring defaults. Okay, so if we're pattern matching with multiple clauses, so in this case we have a default. Okay, yep, this is cool. All right, so we're pattern matching. We're creating two functions. One takes two arguments, and we have a guard that's making sure that B is not nil, or is nil, sorry. And then we're just returning A because we're ignoring the third argument. If B is nil, we're just returning A, so we're not concatenating anything. And then if A, B, and the separator are there, we're concatenating it like we did before. And the default head declaring, or the function head, which is where we have defaults. So if we just pass in one value, it's automatically setting B to nil and the separator to a space. And in this case, we always have to have the function head for the multiple clauses. And if you notice, like, it's just the function head. You're not doing any of the work. We're just declaring the default values. So let's go back into VS Code and let's rework our concat script a little bit. So we now have our join function. All right, I'm going to just copy this. All right, and paste, because now we have our separator. So we have one function here. And then we have one function here. I'm going to copy this as well. So we just have our function head up above. And by default, we're going to set B to nil and the separator to a space. And if we're ignoring the separator, so we're not using that in this function, and we're only going to call this function when B is nil. So if B is nil, we ignore whatever separator is being passed in, and we're just returning A. So let's add our guard here. So when is nil B. Okay, so save that. I'm going to just comment out our IO puts here. And if we jump back over to our whatchamacallit, shell. Now we can compile this, and what was this called? Concat.exs. Okay, so now if we do concat.join, and if we pass in hello and world, we get hello world, and by default the separator is a space. And if we were to do that again, but this time declare our separator, it still works. And then if we don't pass in anything for world or our separator, we just get hello back, so A. So our little pattern matching, our multiple functions is working, or our multiple clauses. All right, I'm going to clear this so we can be at the top again. And let's jump back over to Firefox. All right, do we have any questions? Seems like everything is good. So we will continue reading. All right, so when a variable is not used by a function or clause, we add the leading underscore. Okay, like we've talked about this, I think, quite a bit, but to its name to signal this intent. So I feel like I just read that really weird. When a variable is not used by a function or a clause, we add the leading underscore to its name to signal this intent. So up here, we added the underscore to the separator because our intent is to not use it. And this rule is also covered in the naming conventions document, which I'm making a note of because we're doing a video on that. So when using default values, one must be careful to avoid overlapping function definitions. Consider the following example. All right, so first join, second join. All right, so we have a function here, join, that takes two arguments, A and B. And then it's joining them. Okay, oh, this is a good example. Elixir will emit the following warning. This clause cannot match because the previous clause at line 2 always matches. So what is happening here? Let's go ahead and adjust our code a little bit. Okay, so if we have join, I'm just going to do this, I guess. Oh wait, we'll leave one of them. I'm going to comment this out. And by default, this is going to be a space. And then if we create a function above it Did I do it the wrong way? I did. Backslash. Okay. So if we do def join and then just take A and B and do, and then we're going to just concatenate A and B together. All right. And let's see. Second join, first join, IO puts, couple asterisks, first join, IO puts, second join. Okay, so now if we go and try to compile this. Okay, so we get our warnings, redefining. So this clause for join 2 cannot be matched because a previous clause at line 8 will always match. So let's see, line 8. Okay, so since we have the default value, it's assuming that we're not passing in the separator. But if we only pass in A and B, it's going to match in the order that it goes. So the compiler tells us this function's never going to be called. So we'll never have a space in our output. So if we go ahead and do concat.join, what's happening? Concat.join, and if we pass in hello and world, undefined function. Am I spelling? Oh, I'm spelling things wrong. Concat.join. So we don't by default have a space, so it just concatenated them together. So order of operations matter. And so if you do have multiple functions like this, that's why it's important to have the, what did they call this? The default case clause, function head clause, right? So that's cool. That's cool to see. All right, so Elixir will emit the following warning, correct? The compiler is telling us that invoking the join function with 2 arguments will always choose the first definition of join, whereas the second one will only be invoked when 3 arguments are passed. Okay, so by default, we're never going to have the space unless we're passing in the argument. So let's go ahead and do that. And so now if we passed in a space, it would work. And then if we also pass in our underscore, that works as well. But if it's always 2 arguments, it would never hit that second case function or function clause. So removing the default argument in this case will fix the warning. So that makes sense. So if we go back to our code and we have it either takes 2 parameters, right? Or you have to pass in 3. Now with pattern matching, it will always work. So if we go ahead and compile it, we don't get that same warning anymore. All right, cool. Back to our documentation. So this finishes our short introduction to modules. In the next chapters, we will learn how to use function definitions for recursion and later on explore more functionality related to modules. So recursion's next. Recursion is a fun topic. I love recursion. I remember when I first was learning recursion and it hurt my brain. Would you make an example for real-time system? I don't know what you're asking, but in this live stream, I'm just going through the Elixir Getting Started documentation. But I have a lot of content on my page for building Phoenix live view apps and Elixir APIs and things like that. A real-time system example for Phoenix and Next.js. I don't know. It's not likely I'm going to do a Next.js video, but you never know where the future takes us. I would check out my live view videos if you want to do some cool stuff. There's a lot of guys out there doing cool stuff with Vue, and I'm trying to think of some other cool. I'm going blank, but I had a lot of good podcast guests on with this stuff. Yeah, thank you, Sasha, for always being here. I appreciate it, guys. And I will see you. I think I'll do this on Thursday. We'll go over the recursion section on the Getting Started guide. So thanks a lot, guys. Thanks for joining, and I'll see you in the next stream.
Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.